Bismillahirrahmanirrahim. My name is Gohar Ayub and I welcome you all on the page of the Learning House Coaching Academy. Today we are going to start the new chapter which is of 9th class. The name of the chapter is Real and Complex Numbers. First we are going to explain what are real numbers, what are the operations on the real numbers, what are the properties which are very important, very necessary for the real numbers, and then we will try to solve, we will learn how to add the real numbers and subtract, and then we will try to solve the real numbers, we will depict the real numbers onto the number line. Then we will move on to the exercise which relates the complex numbers. So there are two topics in this chapter: the operations of real numbers and the operation of complex numbers. So these are two individual topics and we will discuss the topics one by one. So first of all, we are going to start this chapter with the topic which is the real numbers. The first most important thing is the definition of the real numbers, that what are actually the real numbers. But before going into real numbers, we must know some other type of sets, some other type of numbers which are also very important. But before going into the real numbers, we must know that numbers. We already know that in lower classes we have already learned that what are natural numbers. The set which starts from 1, 2, 3, 4 and up to so on. This is the set of natural numbers and they are represented by a capital letter N. Then the set of whole numbers which is being represented by W, capital W, and that set includes 0 as well as all the natural numbers. It means 0 plus 1 plus 2 plus 3 plus 4 and plus 5 and so on. Then there is a set of integers which is being represented by letter Z, and this set includes 0 and all the positive numbers and as well as all the negative numbers. You can also see its representation in this way, that 0 plus 1 plus 2 plus 3 and plus 4 up to so on, and then minus 1, minus 2, minus 3 and so on. You can even write the integers in this way. Then there is a turn of positive integers. The positive integers are all the positive numbers. I mean to say all the numbers which are positive, means 1, 2, 3, 4 and up to so on. Same is the case with negative integers. Negative integer includes -1, -2, -3, -4 and so on. Remember, this 0 is in between, is a margin, is not a positive number, not a negative number. So when we write the positive integers or negative integers, we don't mention 0 over in that sense. Then there is a set of even numbers. All those numbers which can be written in the form of 2k, where k belongs to integers. All those numbers which will be represented by this formula 2k, where if I put the value of k which is integers, I mean to say if I put 0, it will become 0. If I put plus 1, it will become 2, plus 1 will be multiplied by 2, it will give us plus 2. Then if I put plus 2 in the place of 2, in the place of k, it will give us plus 4 and so on. But if I put all the negative values, for example, I put the negative value of integers -1, so -1 into -2 will be -2, -4 and so on. It means the set of even numbers is the set of integers which are divisible by 2 or which are the factors of 2. Means 0 multiplied by 2 is 0, 0 multiplied by 1 is 2, 0 multiplied by 2 is 4, 2 multiplied by 2 is 4, 2 multiplied by 3 is 6. All those numbers which can be divisible for smaller classes, lower levels, we also mentioned that numbers. we mentioned even numbers, that those numbers which are divisible by 2, 4, 6, 8, 10, and 10 also includes 0. So 0 is also an even number. But in higher classes you will study, or teachers will tell you that all those numbers which can be written in the form of 2k, where k belongs to integers. It means if I put the value of integers in place of k, the new numbers, the set which is taken out by the formula 2k will be the set of even numbers. Same is the case with odd numbers. All those numbers which can be written in the form of 2k plus 1, where k is still the integers, then we will see that all the numbers will be like this: plus minus 1, plus minus 3, plus minus 5, and so on. These are the set of odd numbers. Same prime numbers, we have another set which is set of prime numbers. A number which is only and only divisible by two numbers, which is only itself or 1. I mean to say, a number which is the factor of only 1 and itself, means it has only two factors. That number is called a prime number. For example, the prime number is 2, 3, 5, 7, 11, 13, 17. These are all prime numbers. Prime numbers are represented by capital letter P. Then there is a set of composite numbers. Composite numbers. All those numbers which have more than two factors are called composite numbers. They are 4, 6, 8, 9, 10, 12, 14, and so on. These are those numbers which are divisible by itself by 1, and there is another factor, or maybe more than one factor, maybe more than two factors, which can divide these numbers. So such numbers are called composite numbers. Now, this is all the old theory which you have already studied in the lower classes. Let's discuss the real numbers. Real numbers is a set which can be written as the combination, the union of rational and irrational numbers. The real numbers can be represented by the union of a set which includes rational numbers as well as irrational numbers. These are called. So, first of all, it means if you want to learn the set of real numbers, or you want to learn the real numbers, you must know what are rational numbers and what are irrational numbers. So first I will define what are rational numbers, and then later I will define the irrational numbers. Let me describe rational numbers first. Real number can be represented by this type of R, and rational number is represented by letter Q. Rational numbers are all those numbers which can be written in the form of P by Q, which can be converted in the form of P by Q. Any numbers which can be written in the form of P by Q where Q is not equal to 0, all those numbers are called rational numbers. Later the mathematicians said that if we have a fraction number, all the fraction numbers which can be converted into decimal numbers. It means if I write 2 by 5, if I write 3 by 7, if I write 2 by 4, or maybe 2 by 3, these are some different type of fractions. If I divide this fraction number, for example, I divide 5 by 2, so I write 5 and 2. 2 times 2 is 4, and then decimal point 2 into 5 is 10. It means that 2 by 5 will give us 2.5. Isn't it? If I divide 7 by 3, 3 by 7, it will give us 3. I'll put decimal here, 3, then 2, 6, You will get 5 again. You will get 5. You will get 1. And you get 3 again, which is this. It means this will repeat itself. It means 0.428571 and it will repeat again 428571. So when a fraction number repeats itself, we mark a sign of dash over it. This sign means that this number will be repeated again. Let's solve this one. Now it's the turn of 2 by 3. If I divide 2 by 3, I'll put decimal 0, 3, 6. 3 times 6 is 18. I'll get 2, again 6, then again 18. Then 2, it means this 6 will repeat itself. It means 0.666 and this 6 will repeat, or I can also write this 0.6 and a dash, a point, decimal point over 6, which also means that this 6 will repeat itself. You will see in this that when I divide a fraction number can be converted into 3 forms. Maybe it will finish, it will terminate. So such type of decimal number is called terminating decimal. And some will not terminate. For example, these two. You have noticed that it will repeat itself and it is also repeating itself. They are called repeating or recurring decimals. They are called recurring decimals. So these are 3 numbers which are terminating or recurring or recurring. These 3 are recurring numbers, but there are some other numbers. For example, square root of 3. We already know that square root, if we simplify the square root of 3, it will not be a terminating, it will not be a recurring decimal. It means this is called non-terminating and non-recurring decimal. Remember that all those numbers which are either terminating or recurring, I mean to say this one also, these are all rational numbers. And the numbers which are not terminating, non-terminating, non-recurring, the square root of 5, the square root of 7, the cube root of 4, or any numbers which if I simplify and will not terminate or will not recur, will not repeat itself, are all, these are all n plus. The value of y, the epsilon, the golden angle, these are few very important irrational numbers. They are called irrational numbers. These are the irrational numbers. In exercise 1.1, when you will start the exercise, you will see that there are few questions in the exercise in which the first question is, they will give you some numbers and they'll ask you that find whether these numbers are natural numbers or integers or rational numbers or irrational numbers. Remember that all the numbers which are natural numbers, for example 1, 2, 3, 4, 5, 6, 7, these are all natural numbers. All the natural numbers can be written in the form of p by q, because we already know there is a 1 in the denominator in every number. So these are all rational numbers. And also 1 is a terminating number, 2 is also terminating a complete number, 3 is a complete number, it is a terminating 4, 5, and all the natural numbers, all the integers, all the prime numbers, all the composite numbers are all rational numbers. They are all rational numbers, but the numbers which are not recurring and non-terminating are all irrational numbers. For example, the value of this, the value of this. Remember one more thing. The value of pi is not equal to the value of 22 by 7. Because when we solve 22 by 7, you will see it will give us a recurring decimal, which is equal to 3.142857. And it will repeat again, and it will repeat again, and it will repeat again. But the value of pi is 3.14 and then 3 and up to so on, and it will not repeat, it will not terminate. So there is a confusion. If there is a confusion in your mind, in lower classes the teacher might have told you that the value of pi is equal to 22 by 7. It was only for the sake of simplification. Even in modern books you will see they say use the value of pi 22 by 7, but they won't say that the value of pi is 22 by 7. Sometimes they even write this thing, that pi is almost equal to 22 by 7, because the value of pi, if I write the value of pi, it is 3.143 and non-repeating decimal, and here it is also this. So you will see in first 3 decimal numbers are both same. So therefore they use that value. They use pi as 22 by 7, but they both are not same values. Remember that. If you get a chance where they ask you what is 22 pi, so you will say it is an irrational number, but 22 by 7 is not an irrational number, it is a rational number because it is a recurring decimal number. So remember that. Also, in the next question, after this question, when they will ask you that find out which of the number are rational or irrational or terminating or not terminating, the next question is changing any number into decimal. And I have already done so many examples in which I have divided the numbers and I have converted the numbers into decimal form, so I won't go into that topic, but the next topic is very important. For example, the next topic is for example, depict the number onto number line. What is number line? A number line is a line which represents all the integers over it. This is a number line. For example, if they say depict or represent 3 onto this number line, so how I am going to solve it? I'll mark this 3 with a solid ball and it will show that I am representing number 3 on it. If they say represent this number, it means I cannot represent that number directly onto that number. So first I have to convert that number into decimal form. So I will then divide this number first and it will give us 2.5. It means the number is in between 3 and 2. 2.5 means that it is in between, exactly in between them. This number shows that it is actually 5 by 2. You can clearly see that the half of 3 and 2 is actually 2.5. So this number is representing 5 by 2. For example, this number, it will give us minus 4.5, which means the number is in between minus 4 and minus 5, somewhere in between this number, and it will show us that this number is representing minus 9 by 2. The problem arises when there is a number which is an irrational, which is a rational number but a recurring decimal. That how we will represent a recurring decimal over that. For example, I have a number which is 4.55. How I am going to represent that number? In chapter number 1 of physics, when you study the measurements and the scales in physics, you must have learned that in physics or mathematics, we mostly take the approximate values. It means that we are taking 4.55, it can be 4.555555 up to so on, but we have only taken up to 2 decimal place because it depends on the scale which we are taking. Let's say I have a scale a ruler, which is a very good scale because all the numbers, all the intervals are equally divided between each other. If I take 4 and I write 5, and there are 10 equal scales in between them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 and 10. This is 5. It means this number is representing 4.1, this is 4.2, this is 4.3, this is 4.4, this is 4.5, this is 4.6, this is 4.7, this is 4.8, this is 4.9. If I want to represent 4.5 only, it will be somewhere here. And if I want to apply 4.55, so it means it will be in between 4.5 and 4.56, somewhere here. It will represent us 4.55. Isn't it? But let's see. The number is 4.55. It means we need to zoom in that particular number line. And if we zoom into this particular number line, and if I take only these two numbers. For example, I take only these two numbers, which are, one is 4.5 and one is 4.6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It means this is 4.51, this is 4.52, this is 4.53, this is 4.54. This is 4.55, 4.56, 4.57, 4.58, 4.59. It means if I want to represent the number which is 4.555, if it is only 4.5, it will be here. And if it is 4.55, it will be in between these two. It means this number is actually representing 4.555. If we want to take 4.5555, it means up to this. So I have to zoom in this one. So instead of writing this, I'll write 4.55 here and I'll write 4.56 here. I'll write these two and then zoom in. It means it will zoom in, it will get bigger, it will give us more broader picture of the number line. So it will become this 4.55, it will become 4.551, 4.552, 4.553, 4.554, 4.555, 4.556, 4.557, 4.558 and 4.559, and this is 4.560 and it is 4.50. It means if I want to plot this number, it will be somewhere in between 4.555 and 556, somewhere here. If you want to get it bigger, you want to make a bigger scale, you have to zoom in that scale and then get into that scale, and you can mark any kind of irrational number on it. A terminating number, a recurring number on it. But it depends upon you that up to what decimal place you want to move in. You want to zoom in, you want to get in. So that is how you are going to plot the numbers. I hope you understand the topic today. This was exercise 2.1, or I would say it was the first part of the real numbers. It was where you can find out the natural numbers, you can find out the where you can find the natural numbers, the real numbers, the rational numbers, and then you can depict the numbers onto number line. So I hope I answered all your questions and queries. Please do like the page, must subscribe the channel and share it with your friends so others can take advantage from that page. Thank you very much for today. We'll join you tomorrow, inshallah.